Pedigree analysis is the analysis of family trees, and by looking at a family tree you can make certain predictions about the genotype of the individuals. When looking at a pedigree, ask yourself these questions before analyzing. First of all, is the condition sex-linked or is it autosomal, which means non-sex linked? So can the allele for the condition be found on an X chromosome or not? If mostly males have the condition, then it's probably sex-linked. It is possible but relatively unlikely for women also to have this condition, because this would mean that both parents of the woman must carry the allele, which is normally rather unlikely, but not impossible. And it is autosomal, non-sex-linked, if both genders more or less are equally affected. So if you see in the pedigree males and females to have the condition, then it's probably autosomal at equal percentages. The second question: is the condition dominant or is it recessive? To simplify, if let's say we use in this case A as the allele, if it's dominant, if the person carries the dominant allele, then he is affected in this case. If it's a recessive condition, the person is affected if he or she has 2 times the recessive allele. It's recessive if 2 unaffected parents have an affected child. That's a strong sign already. It's also recessive if the condition skips generations. So if the grandparents have it, the parents not, and the children again have it, it skips the parental generation, then it's also possibly recessive. And it's dominant if many people, also irrespective of gender, in the pedigree are affected, and also in every generation. So look at the number of people who are affected. And conditions which are sex-linked are usually recessive and also linked to the X chromosome and not to the Y chromosome. The other things also exist, they're relatively rare. So we're only going to cover these examples with X-linked, sex-linked conditions. Let's have a look at a few of these pedigrees and let's analyze them. This is a pedigree over here showing parents and children, and one child over here, in this case a boy, a male, is affected. The question is now, is this condition sex-linked or autosomal? We don't know that yet. We'll find out. Is it dominant or is it recessive? This is now easier to figure out. It is most likely recessive because 2 parents who are not affected have an affected child. Let's see if this works. This child over here, let's say, has little a, is affected. In this case, each parent up here must also have the recessive allele, but because they are normal, they're not affected, there must be the dominant allele present as well. So, does it work with recessive? Yes, it does. Now, what about sex linkage? Is it possible for the condition to be also sex linked? And as a matter of fact, it is possible, theoretically. If it's sex-linked, then we know this must be a boy, so has XY. The boy is affected, has a lowercase a over here. Both parents are not affected. This is the mother, must have XX. Over here, this is the father, XY. The boy down here inherited the Y chromosome from the father and must have inherited the recessive allele from the mother. But the mother is not affected. So there must be a capital A up here. The father is also not affected. There must be a capital A up here. So this too is a possibility. So it's recessive, and it theoretically could also be sex-linked. Now, we only see one boy being affected over here because the pedigree is relatively small. So to be more certain, we need a bigger pedigree. Let's move on to the next example. So also possibly, we don't know that, but possibly also sex-linked. Here, this pedigree is slightly larger. Sex-linked or not, boy, girl, 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 boy, both genders equally affected more or less. I think it's pretty much autosomal. Is it a dominant or recessive condition? There are relatively many people are affected, so my first assumption would be that it is a dominant condition, but let's check if this works. So let's try this one over here. This girl over here is affected. We'll use capital A for the allele carrying the disorder, and let's assume we don't know more, but this one over here, this mother, is not affected, must have lowercase a, assuming the thing is dominant, the condition is dominant. The father over here must have a capital A dominant allele, because he's affected, and he inherited that allele to his daughter. And the mother, who is not affected, then must have inherited her lowercase a also to the daughter. So this works. We do not know anything about the second allele over here, but yeah, not yet at least. Let's try to find this out. Over here, mother lowercase a, but this son over here is not affected. So there must be a second lowercase a over here, which he must obtain from the father. So I now know that there must be a lowercase a over here, and the father is heterozygous. So it is most likely indeed an autosomal dominant condition, also looking at the number of individuals who are affected. But let's now move on to the next example. Over here, there are now fewer people who are affected. I therefore assume it is not sex-linked, boys and girls. It's probably, again, autosomal. Is it recessive? Does the recessive inheritance work? We assume that, and we now test it. Lowercase a, affected father. Over here, a mother who is not affected, she must have at least a capital A. This girl over here is lowercase a. If this is the case, the mother must have also a lowercase a over here. So it works like this. And then one of these two alleles. So that works. Let's try this one over here. Is this a possibility? There must be at least a capital A over here from the mother, and a lowercase a, the recessive allele from the father. So also this works. So it most likely is a recessive condition, also looking at the relatively few number of individuals who are affected, because over here the condition does not show up in the children here. So also possibly a recessive condition. Next example, sex-linked or autosomal, boy, girl, most likely autosomal. Dominant or recessive, look, it skips one generation, already a strong sign that it is recessive. Let's test it. Lowercase a. If this is indeed the case, then each one of the parents here must have a lowercase a. They are not affected. They must also have the dominant allele, otherwise they would be colored in. They're not. So over here, this lowercase a must have been inherited from the affected father. And this capital A over here, the dominant one, must have been inherited from the mother. Because the father is affected, there must be a second lowercase a over here. And about the mother, we don't know. No, of course we know. No, we don't know what the second allele is. We know that she is dominant because she's not affected, but the second one we don't know. So we'd have to look again one generation higher, because each one of them are not affected. They could theoretically have inherited the dominant allele from the mother, but because there are so many children over here, actually all of them, who are not affected, I would highly suppose that the second allele is dominant here as well. Otherwise, we would expect about 50% of the children to be affected. So it's a capital A, and over here each a lowercase a. Okay, so let's move on to the next example. The next example is this one over here, sex-linked or autosomal. Boy, boy, boy. I assume it is most likely sex-linked. Let's see if this works. This is the mother, XX, XY. This boy over here has XY. The Y chromosome inherited from the father. The father himself is not ill, so there must be a dominant allele over here. The mother is not ill. There must be a dominant allele over here. But the boy, the son, is affected. There must be a lowercase a. Now, where does this lowercase a, the recessive sex-linked allele, come from? It must come from the mother, who is a carrier. So yes, this indeed works. The same thing you can see over here as well. We have over here a father who is not affected, and over here a girl who certainly must have the X, the lowercase, the recessive allele from the mother. Okay, so this was an overview of a pedigree analysis. Try it out, take it systematically. Examples in exam questions are usually quite clear, so there is probably not as much guessing around as I've done right now.